Good evening, ladies and gentlemen, colleagues, cameras, and connections. This episode is about quantum information processing and quantum information. Computer engineers typically describe a modern computer's operation in terms of classical electrodynamics. In these classical computers, some components such as semiconductors and random number generators may rely on quantum behavior. However, because they are not isolated from their environment, any quantum information eventually quickly decoheres, while programmers may depend on probability theory while designing a randomized algorithm. Quantum mechanical notions such as superposition and wave interference are largely irrelevant in program analysis. Quantum programs, in contrast, rely on precise control of coherent quantum systems. Physicists describe these systems mathematically using linear algebra, complex numbers model, probability amplitude vectors model, quantum states, and Mainz model to operation that can be performed on these states. Programming a quantum computer is then a matter of composing operations in such a way that the resulting program computes useful in theory and is implementable in practice. As physical Charlie Bennet describes the relationship between quantum and the classical computers. A classical computer is a quantum computer, so we couldn't be asking about where do quantum speedups come from. We should say well, all computers are quantum. When do classical slowdowns come from? Where do classical now we'll be speaking about quantum information. Just as the bit of the basic concept of classical information theory, the qubit is the fundamental unit of quantum information. The same term qubit is used to refer to an abstract mathematical model and to any physical system that is represented by that model. A classical bit, by definition, exists in the earlier quantum information. This is a qubit is the basic unit of any quantum information. Bit is the unit of any binary information. These definitions you should understand, practice, then something can be said about quantum computing. Thank you. Thank you so much.